Okay, so this is the review for Chapter 7 for your final. Number 1, suppose that y varies directly with x. Alright, we know that when y varies directly, it's y equals a number k or a constant k times x. They asked me if if y is equal to 4, then x is equal to negative 2. Find x when y is equal to 6. So we're going to plug in 4 and negative 2 in for x and y so that we can solve for k first. Divide both sides by negative 2. You'll see that k is also equal to negative 2. I'm going to rewrite the equation, my direct variation, as y is equal to negative 2x. Now I can find x when y is 6. So 6 is equal to negative 2 times x. Divide by negative 2, and we'll see that x is equal to negative 3. C. Number 2 is very similar in that the only difference though is that y and x vary inversely. So now instead of y is equal to k times x, our function is y is equal to k divided by x. So when x is 4, y is equal to 10. I can use that to solve for k by multiplying both sides by 4. And that'll get me a k of 40. Once I have k, I can rewrite my function as y is equal to 40 over x, and I can find y when x is negative 5. So y is equal to 40 over negative 5. Your y is negative 8. 8. In number 3, we're supposed to just multiply. Okay. We're not really going to multiply, we're just going to factor everything and see what reduces and cancels out. Okay. So x squared plus 3x, that looks like I can take out a greatest common factor of x, and I'm left with x plus 3 left over. X plus 4 cannot be factored, so that remains. X squared plus 6x plus 8. What multiplies to 8 and adds up to 6 is 4 and 2. So that factors to x plus 4, x plus 2. And x squared minus 9 is a difference of 2 squares. That is x plus 3, x minus 3. So looking for things to reduce, these x plus 4s will reduce. This x plus 3 will reduce. And I believe that's it. So all we have left over is an x on the top, an x plus 2 on the top, and an x minus 3 on the bottom. And that gives us D. Okay. So number 4 asks us to sketch the graph of the equation y is equal to 1 over x plus 5 plus 3. So using kind of our shortcut tricks of transformations, we know that x plus 5 means a shift to the left 5, and plus 3 means a shift up 3. Well, the parent function of y equals 1 over x is positive. That's a positive 1 over x. So that I know kind of if these were the asymptotes, my graph would look something like this. So I try to find a graph. Well, C is definitely not correct because C is only a line and not an inverse variation graph. I need to find something that got shifted to the left 5. A got shifted to the right 5, so they can't be it. B and D looks like they both got shifted to the left 5 and up 3. We need to find which ones are in the correct quadrant. It should be in quadrant 1 and 3 because our function was positive. So it's got to be B and not D. Okay. In number 5, we're asked to divide. So it's like multiplication. We're going to factor and reduce. The only thing different is that we need to take the reciprocal of the second fraction and change it to a multiplication problem. So the first fraction, y squared minus 4y plus 3, to factor that, I need to think what multiplies in 3 and adds up to negative 4. Well, that's negative 3 and negative 1. So that's y minus 3, y minus 1 on the top. I'm actually going to write it somewhere else. So down here. So y minus 3, y minus 1, and 5y cubed remains. Multiply this time. The 15y squared is at the top now, and the y minus 3 is at the bottom now. The y minus 3's reduce. The y squared can reduce with the y third, leaving only one y left at the bottom. And 15 over 5 reduces to just 3 on top. So rewriting everything, I have a 3 left over on top, a y minus 1, and a y at the bottom. Sorry. So that answer is A. Number 6, we're asked to simplify, which is just they want us to add. So you may remember when we need to add, we need to make sure that our denominators are the same at the bottom. And so we're just looking at the bottoms, so we want our denominators the same. So first of all, we should factor our denominators to see if they do have something in common first. So the only thing that factors is m squared minus 9. That's m plus 3 and an m minus 3. So looking at this, I need to figure out what the first fraction is missing that the second one has. And the second one has an m minus 3. So I'm going to multiply the top and bottom by m minus 3. I'm not trying to clear out the fractions. I want to keep the fractions so that I can add them. The second fraction is actually not missing anything. So the first fraction I'm going to distribute. That's going to give me m squared minus 3m. It looks like all the answers have m squared minus 9 on the bottom, so I'm going to just go ahead and distribute that out and say that's m squared minus 9. M plus 3 times m minus 3 is m squared plus 9, or sorry, minus 9. Alright, and the second fraction I can keep 9m over m squared minus 9. Combining like terms at the top, that's m squared minus 3, excuse me, negative 3m and plus 9m is a positive 6m over m squared minus 9. Now, you can factor the top some more by taking out an m, but that's not going to get anything to cancel or reduce, so I think our answer is going to be just C. And 7 is kind of the same type of problem, except we're going to be subtracting this time. So the only thing different when you're subtracting is you need to make sure you change the sign on the second fraction. So I'm going to change this to an addition, a negative 2x, and then a positive 4 over there. So again, I decide what the first fraction is missing that the second fraction has. And the second fraction has a 4 that the first one does not. So I'm going to go with times 4 over 4. The second fraction is missing another y. This has y squared in it. So the second fraction is missing another y. So distributing, this is 20y plus 8 over 4xy squared plus distributing negative 2xy plus 4y all over 4xy squared. Notice how the denominators are the exact same now. I can add on the top or combine like terms at the top. 20y and 4y is 24y. That's a negative 2xy and a plus 8. I notice that all these numbers at the top are reducible by 2. Like they're all even. So let me factor out a 2 and see if I can help reduce to get to the bottom. Because the only thing with 4xy squared is a, but none of the tops make any sense with my answer. So if I factor out a 2, that's 12y minus xy plus 4 all over 4xy squared. Well, this 2 can reduce that 4 to be a 2 at the bottom. So my answer is 12y minus xy plus 4 over 2xy squared, which is B. Okay. And one of these working together problems. Right? Nicole can clean the house in 5 hours. So that's a 1 over 5. Friend Chris comes over and they together can clean the house in 3 hours. Okay, so that's a 1 over 3 over here because they were working together. We need to figure out how long it takes Chris to clean the house. Okay, so that's the equation we set up. I need to find something that'll clear all the fractions, and since I'm solving, I just multiply the tops. If I'm adding and subtracting, I'll multiply the top and bottom and then just combine them. So I think 15r will clear out everything. So 15r divided by 5 is 3r. 15r divided by r is 15. And 15r divided by 3 is 5r. That's a much simpler equation to solve. If I subtract 3r from both sides, I get 15 equals 2r, and then divide by 2, and Chris would have taken 7.5 hours to finish. D. Okay. Number 9, I'm supposed to solve this equation. So I look for something. I want to get rid of the fractions. Anytime I'm solving equations, I don't want fractions in it. I want to look at the denominators and see what I should multiply by to get rid of all the denominators. And I think I can get away with multiplying everything by x squared. So that's going to give me 1 times x squared is x squared. X squared divided by x squared is just 1. 3x squared divided by x is 3x. Okay, so this is a quadratic, so I'm going to try to get everything on one side. I'm going to move the 3x over, and I get x squared minus 3x plus 1 equals 0. Okay. Looking at the answers real quickly, I'm pretty sure this can't be factorable, so I'm going to end up having to use the quadratic formula. So 3 plus or minus negative 3 squared minus 4 times 1 all over 2 times 1. This remains 3 plus or minus. This is 9 minus 4, which is 5 all over 2. So this should be 3 plus or minus square root of 5 all divided by 2. And they kind of wrote it really odd and split this up really oddly. So let's go ahead and cancel out C and D because they have 13 instead of 5. The difference between these two is that here the 2 is only underneath the 5. Okay. And here the 2 is underneath both. So when you're using quadratic formula, it's all over 2. Both of these are being divided by 2. So they split it up weird and wrote it like this. Okay, they split it up into 2 fractions. 3 over 2 plus or minus square root of 5 over 2. That's a strange way to split it up, but that's the same answer.